All right, I'm getting a thumbs up, so we're all good. Oh, well, always with these, we have last minute things, but it's no good. And I'm happy that y'all can do thumbs up because that means that I at least can communicate with you a little bit. But we are going to get into it, and we're going to start this webinar session about securing your lovable applications, all vibes, no vulns. So just to start off, I'm going to get straight into it, but a little bit about me. If you're wondering where my accent's from, I'm from Aotearoa or New Zealand. I live now in the Netherlands, and I work for a Belgian company just to keep everyone guessing. And you'll be able to find me anywhere on the handle @AdvocateMac. So if you want to follow some of the things that we're doing, that's where you can. But enough about that. I want to get straight into it. So this is coming to you from Aikido. Now, if you've never heard of Aikido before, we are a security platform. And we really pride ourselves on a security platform for devs. And we kind of call ourselves the no BS security platform. And basically all we're trying to do is make sure that we can keep everyone as secure as possible, giving them all the successful information. And we've really seen some of the trends with vibe coding, and we're wanting to kind of enter into this space and allow people to be able to kind of understand security on their applications. So one of the first questions that I think everyone has is, and there is so much debate about this in the security world, that is AI coding good or bad for security? And like there was this post that went really viral here, it had over 2 million views, where it was talking about how this person has made a website, this time with Cursor, another AI tool, and it was getting all these attacks and all these things. So is AI coding good or bad for security? And my honest answer is I don't think it really matters, because it's here to stay. But what I will say is that it definitely does create a lot of vulnerable websites. And if you're not careful, then your website or your application can absolutely be vulnerable. And we're going to go through here today to discuss, how we can solve that. One of the things that I want to kind of point out here is that there's a lot of negativity around AI coding platforms, particularly from security. And one of the things is I want to make clear is that we're not here to bash Lovable. I think everyone here probably could agree, or most people here would agree, that Lovable is quite cool in what it can create. But what it does create is vulnerable, kind of almost always out of the box. So we're here to kind of discuss some of the things with that. So we're not here to bash Lovable, but we are here to secure it. And the last thing before we kind of get into some of it is there's a lot of very unhelpful information out there on the internet. And one of the things that I kind of see recently is when people are asking questions about security, you'll get a lot of answers that are along the lines of learn to code or like learn to do this. What I will say is there is going to be some learning curves when it comes to building and maintaining an application if it becomes successful. I don't necessarily believe that you need to become a 10x coder anymore to be able to create something successful. You are, however, going to need to learn a few things about security, and that's going to be really important to do that. So that's kind of the learning curve that I want to go down here. You don't need to go back to university and learn how to be a coder from scratch. You do, however, need to learn a few things when it comes to security. So what do you need to be secure? So what I wanted to do is I wanted to break this up into a couple of things. And there's a couple of very critical things that I think everyone needs to learn urgently. There's a lot of tools and things that you should learn. And there's a couple of things that when you get down your journey, you should kind of continue on and learn more about. The two things that I'm going to spend the most amount of time on today and really understanding this is going to be secrets detection and authentication and design flaws within your application. And that second one is really going to be around something called RLS, which is row level security. I'm going to explain what that is. But that is essentially, in Lovable, kind of the absolute pillar that's going to be holding up your site here. Some of the other things we're going to talk about is DAST, dynamic scanning of your application. This is a tool that scans your application for vulnerabilities. SCA, this is a tool that scans your dependencies. We'll talk about that. Static code analysis, and firewalls. So we're going to cover all of these things in this webinar, but the thing that we're going to take the most amount of time on is going to be those first two. So one of the things that I've done is I've created my own Lovable site. And I got to say, it's really cool what you can do very quickly. So this site has a couple of areas for it. So it has kind of authentication. This is quite cool because it works with Google and other third-party services. I have the all-important admin panel down here. Now, the admin panel is really important for my site because it's a new site. And essentially, being able to add and edit these articles, I need to be logged in as an admin. So it's extremely important. If you can imagine if this became a very popular site, that having access, having that admin control kind of, not having that would allow anyone to be able to create this. So we obviously don't want that. And some other little cool features, like I created a subscribe bundle that's connected to Mailgun, a third-party service. And all of this works really well. There's search functions. I've got different areas. I think that this is a really cool site. The problem is that right now, this has some very catastrophic business-destroying vulnerabilities within it that really make this vulnerable at a number of different levels. I'm going to go through some of them. A lot of you put forward your websites, your application, your Lovable applications to us. You gave them to us, and we did scan a lot of them. And I can say that a very large proportion of them all kind of have very similar vulnerabilities. And so what we're going to do is we're going to talk about some of them and how we can secure it today as well. All right. So the first step, if you're brand new and you kind of not, and you wanted to understand, the first step is that we're going to need to sync our Lovable application with something called GitHub. It's very easy to do in your Lovable application. Oh, I need to this. There's a button up here called Sync Your Projects to GitHub. Now, this is really simple, and essentially what that does, if I click on this, it puts all of that source code in a repository, a GitHub repository. Why is this important? Well, this is going to be the main source of truth for us to be able to scan our application and find vulnerabilities within it. So this is kind of a central point. So if you're going to secure your application, it's going to be important that we first sync it to GitHub. This is kind of the easiest way to get it. Lovable also does have a dev mode where you can see the source code. I think it's better if you sync it up with GitHub because this is kind of a more standard way of doing it. So if you're wondering kind of what are the first steps, well, that's going to be the first steps to be able to do that. Next, I kind of just want to talk a little bit about, really understanding your Lovable application. And there's a couple of areas in here. Your application is built up of two elements, essentially. You have your front end. This is what makes it look good. This is what the user experience sees. And then you have your back end. Now, with Lovable, your front end is written by Lovable, usually in TypeScript and JavaScript frameworks. And so this is what Lovable is really adding to the table. Your entire back end, all of the operations is pretty much set up in Supabase. Now, I have been looking into trying to get Lovable to create something outside of Supabase. All I will say on this, because I'm not going to talk about it a lot, is don't. use the connection there with Supabase. This is going to be the way to make it the most secure, is to kind of use the standard functionalities that you have. But understand that all of your security is kind of controlled in how Lovable and Supabase communicate with each other. So it's really extremely important that we understand that connection. Lovable actually doesn't write a lot of code for your backend. This is kind of all handled by Supabase. So Lovable is really only dealing with the front end and then facilitating that initial connection with your backend Supabase. That's essentially how it works. So in understanding security, we're also going to have to understand Supabase quite a lot as well. So I talked a lot about the key elements of what you need to do to secure your application. Now, the first step number one, is something called secrets detection. If you've seen a lot, if you've looked anywhere about Lovable, you've seen probably a lot of information out there on Twitter or X, whatever you want to call it, on Reddit, about Lovable exposing your secrets. Secrets are probably just the absolute number one thing that an attacker is going to look for in your application to try and gain access, just because it's kind of like low-hanging fruit. A secret is kind of like a password. So what I'm going to do, I'm going to explain for everyone what secrets are, and then I'm going to go through and look at how we can identify these, how we can discover them, and kind of some of the damages that can happen from there. So what are secrets? Well, on the screen here, you see this kind of it's a .env file. It's called an environment variable file. This can often contain secrets. And this is what secrets look like. They're very long strings, and they're essentially very complex, very long passwords. And how secrets work is that they connect all these different services to your application. So just looking on the right side of the screen here, you have your application. Your application is not a monolith, meaning it's not like some giant piece of code and Lovable has written every single function, everything that it needs to do within it. Instead, it's connecting to a whole bunch of different third parties, and it's connecting via secrets for this. So it's using these secret keys, these long strings to connect. So using like secrets to connect to Okta for authentication maybe, or to some kind of different areas. What's really important is how we deal and how we manage with these secrets. So they typically need to be things like environment variables. The back end can deal with secrets. The front end cannot. What that means in the case of Lovable is that the front of your application should never deal with these secrets here. But often they do end up in here. So for example, here we have a stripe key. This is an extremely extensive key, and it's been hard-coded into a TypeScript file, index.ts. This is kind of common. And essentially what this means is that this key is now going to be exposed on the front end of your application, meaning someone can use it. It's not always that Lovable exposes these secrets. It seems to be in specific scenarios, but it is probably your #1 risk in having a secret exposed. If an attacker can access this, then they can do all kinds of malicious things. It's going to depend on what the secret is for, but secret detection is absolutely the #1 element that you really want to kind of get on top of in your Lovable application. I was debating whether or not to include like this slide, and I don't want to talk about it too much because I think for a lot of people, I really want this to be friendly for people that kind of aren't developers. But there is kind of one element that I just want to touch on so that you're aware of it. And that is, I mentioned before that Lovable is synced to your GitHub account. Secrets are a little bit funny in the sense that most other vulnerabilities, once you solve them, they're no longer a risk. Secrets will remain a risk for you if they're ever hard-coded. Now, what that is something to do with something called your history and your Git history. So in Git or in GitHub, if you want to think about it like that, every version of your application is saved. If a secret is hard-coded, at any point, that secret will remain in your GitHub account. Your GitHub account or your Git repositories will be a target for attackers. So having a secret in there, even if it's private, is a really big risk. So I don't want to talk too much about that, but I just want to let you know, if secrets get exposed in your application, your only course of action is to revoke them and reissue new ones. So even if you remove it from being hard-coded, you add it as a variable or you add it in as an edge function via Superbase, it's still an issue there. So what tools can we use to find secret detection? Now, this is obviously being hosted by Aikido. So obviously, a lot of the tools that we're going to talk about today, Aikido provides. But what I am going to do is I'm also going to provide alternative tools that you can use because I think that you should have the choice. I'm going to be doing all the demos in Aikido. But if you want some other tools for secret detection, there's open source tools like TruffleHog, Git Leaks, or GG Shield. But using Aikido is going to be a whole lot easier in all of these, and I'm going to explain why. So what I want to do is I want to go into my Aikido dashboard. So this is what Aikido looks like. And what I've essentially done is I've connected Aikido to my GitHub repository. And that's done a whole series of different scans to identify different security vulnerabilities. One of the scans is for exposed secrets. So I can just filter on this here. And what that does is it looks through my application to identify any secrets that have been discovered. Now, it has found a couple of secrets. In my specific case, this is not catastrophic, the secrets that have been exposed. However, I have a lot of concerns in particularly one area. So it's found secrets in two areas, in a .env file and your client.ts file. If I look into these files here, if I look at the commit, this here are the secrets that it's committed. It has my Superbase URL and my Superbase publishable key. The keyword here is publishable. You will probably have these keys in your application. It is not the end of the world that these are hard-coded. I don't love it, However, this publishable thing means that this key is meant to be public, and it shouldn't create a security risk because it's been exposed. Lovable actually does a good job of explaining these things to you. If you want to ask Lovable about it, you can simply just tell it that it's found a secret and you want to know exactly why. Get to the bottom, and you want to know exactly why. You can ask it that it's hard-coded a secret. So I'm just going to say, is it a risk my Superbase? And it will be able to tell you whether or not that's a risk or not. For the most part, when it comes to securing your application, I'm going to suggest that you do it through the Lovable interface. It seems to do an okay job to a point. And if you don't have coding experience, I think this is the areas. And there has a couple of things. So it has acknowledged that it is a security risk, but it is also a public key. So it does acknowledge that it's not the best practice, but it's not the worst. I want to go on to something else now, and that is this .env file. If I look at this .env file, you'll actually see that the same two keys have been committed here. This is a much bigger risk, not because of what's in it, but because of the file itself. A .env file, if you have one of these in your GitHub repository, it is a gigantic risk because this file is intended to store sensitive information like secrets. That's what its purpose is. The fact that it's added it into my GitHub repository is really concerning for me because it means that other secrets that get added in my project will also end up in my GitHub repository. So this is much more concerning than at hard coding it. And so what you can do is you can say to Lovable that I have a .env file in my GitHub repo. I'm going to say, can you add a .gitignore? And what this is going to do is it's going to create a file for me called a .gitignore file. Oh, I've encountered an error on that. And what that will do is it will block that .env file from being committed. So if you find the .env file in your repository, it's because you don't have a .gitignore file in there, and Lovable absolutely needs to create one for you. That is a huge risk. So that's the first step. Now, secrets can be exposed in all kinds of ways. They can be exposed in JSON files. They can be hard-coded in source code. They can be in your .env file. It doesn't matter how they're exposed. If they're exposed, it is a big security risk, and we absolutely need to deal with it. And I'm going to show you kind of how easy it is to find these secrets a little bit later on from our application. But that's kind of rule and step number one. Make sure that you don't have secrets in your repository. If you want to find them, you can use a tool like Aikido. Now, Aikido is actually free, so you can join up and you can connect it to your GitHub, and it will scan for secrets. There are other open source or like free tools that you can use. These will be a little bit more complicated to use, but you're welcome to investigate them as well, obviously. All right, I want to move on now away from secrets. I could honestly spend an entire hour talking about secrets. Literally, I could. I just kind of I don't want to because there's other things that we need to talk about. But the other thing that I want to talk about is authentication and design flaws. And this is kind of definitely the scariest thing that I've noticed in Lovable. So what is a design flaw? So a design flaw, which often but not always revolve around authentication, is basically the logic behind how your Lovable application is communicating, is authenticating users, is connecting everything together. If there is a flaw in how this all works, it can be absolutely catastrophic. So for example, like the standard flow is that, a user is asking to select the email from user one, and this is saying, is this user authenticated? If it is, yes. If it's not, no. A logic flaw would be allowing that user to connect directly to the database, for example, without authentication. That would be a very serious design flaw. That is actually happens to be the design flaw that I have in my website, which I will show you. But this is kind of quite scary. And you can do that by kind of making post requests directly to your backend. And if your backend is not set up correctly, it's going to be an issue. Now, I did say at the start that do I think that people need to become developers to be able to secure their sites? I don't think that that's true. However, there is something that if you're using Supabase and you want to stick with Supabase, oh, sorry, Lovable and Supabase, I guess there's something that you need to understand. And that's something called RLS, Row Level Security. This is absolutely critical for everyone listening. And if you only get one thing away from this webinar, it's that you need to investigate your row level security. How Lovable and Supabase connect together is really reliant on the fact that we can expose these public keys in various areas because we have something called row level security, and it really needs to be set up well. And I want to explain how this works because it's so critical to the security of your application. And what I'm going to do is I'm going to show you how I can hack my own site because of the poor RLS policies that Lovable created. So this is how a typical application will work. Let's say that we have a database here, and this database just has, my usernames, their IDs, their emails. This is typical. What typically happens is that a user will make a request via the application, say, hey, show me the data for user one. The application has access to the entire database. So it has access to everything. And then what it does is it applies logic to try and determine, hey, what is user one? In this case, it's Alice Thomas. And it gives that information back to the user. So that's how it kind of typically works. Now, what happens if you have a malicious user that is able to exploit the logic in an application to be able to kind of gain access to things that they're not meant to? So for example, let's say that the user was able to trick the application into thinking it was an admin, and then it's asking for requests for all users. Now, because the only thing that is preventing all users from being exposed is the logic within the application, it's going to give back all of those users. So this is kind of typical before row level security. And I apologize that I have to get a little bit technical, but this is so important. So what does it look like with row level security? Row level security is essentially saying that the application doesn't actually have access to the entire database. What it essentially is saying is that the application only has access to the specific row within the database that is for that one user. So, for example, the same query, the user goes, hey, can you show me the data for user 3? It does that query and then sends back the user for the data for user 3. If we have a malicious user again, and that user goes, show me the data, show me the thing for all of the users, and I'm an admin, and it's trying to exploit the logic, even if the application is tricked, so in this case, maybe SQL injection or something like that, it will still only send back the data for this one user because it's secured on a row by row area. Now, if that's a bit confusing, all you need to know is this, is that essentially the only thing stopping your entire data and everything getting exposed is the fact that you need to have row level security set up really well. So let's have a look. I want to explore this on a kind of a deeper level. So let's have a look here in my Supabase backend. Now here we have all my databases that I have. I have my article database. I have my subscribers database. And essentially, the databases are exposed, but what prevents a malicious user is really is the row level security policies that are set up. So we can have actually a look at those and have a look at the policies that we have. Now, the first thing that you will see is this admin users. I have a warning here that no row level security is set up. Now, I didn't do anything to do this. I didn't change anything. This is just how Lovable set it up. Admin users, probably the most important thing about my website, has no row level security policies. What does that mean? That means that anyone can access the databases or add in their own information in the admin column of my database. So I want to show you kind of what that looks like. Let's have a look. Let's put a hacker hat on. I want to show you what it is, and I'm gonna hack my site. So if I inspect this page, this is going to bring up my developer tools. What I want is I want to try and find those API keys that we have in here. So monitoring the traffic, I see a couple of things. Number one, I see this here. It might be a bit small on your screen, but this here is my Supabase URL with the table that I want, articles. down here is my API key. So I have my API key and I have my lovable URL. Now, I don't love that this API key is exposed so obviously. However, it's a public key, so it shouldn't be the end of the world. But in this case, it is. So let's have a look at that. Let's go back to our database tables, and let's have a look at our admin users table. Here I have 2 admin users, right? And so I'm dealing with this as well. What I'm going to do is I'm going to bring up just some code that I have. Now, this here is the URL for my admin users table. This is my API key. All of this is public. And here is what I want to add into this database. So in this scenario, I'm not authenticated at all. I'm absolutely nothing. But what I'm going to do is I'm just going to make a post command using my terminal. Anyone can do this. So anyone can open up the terminal and you could literally copy and paste this exact same thing. And I want to create an admin user with this password and this email. Now, if I go ahead and do that, I haven't got an error. So let's go back and have a look at our admin table. And if I refresh this, you'll see that there's another admin user in here, Mackenzie at evil.com. And so this is kind of, essentially an admin user has been created to my site with no authentication, no nothing. All of that is because the row level security that Lovable created is basically non-existent. Now there's another area in here too. We have this articles table. So that's pretty catastrophic. And we can do that by establishing row level security. I'm going to go back to my database visualization. And this is my articles thing, my articles tab now. And what I'm going to do is let's go visit this articles thing. Now, if we have a look at our policies, so if I go back to my database, I have a look at the policies, my articles tab actually does have row level security on it. So you can see these are the policies. All right, so sorry about that. There's an articles table here. Sorry, I just had a little technical issue. There's this article table, and you can see here that there are policies applied to this. Now, these policies, there's a couple here. One is saying that it's applied to authenticated role. So this means that only an authenticated person should be able to click into this. And the other area is that we actually see this saying a public role. So what's actually happened? We have conflicting policies here. What that means is that whilst it has only allowed authenticated persons, basically, and in this case, authenticated admins to be able to edit and delete and add articles, it has also allowed the public to do it. So basically, this policy is conflicting. What this means is that the most permissive policy overrides. So what that means is that if you have something that says, hey, a public person can do this and an admin person can do this, the most permissive, in this case, the public one, is the one that is allowed. So I know this is all basically all I'm saying is that not only can I add an admin, I can also add articles for myself. So let's go and have a look at that. Let's do the exact same thing. So I'm going to post up here. Here I have another bit of code from this, and I'm going to go ahead and do that. And what I'm going to do now is if we have a look back at my site, the same process, I can sniff out all these articles. I can sniff out that key. So I'm not doing anything that's not public. But if I go ahead and create this, what I want to do is I want to create an article where I say the website has been hacked. If I go ahead and do that and I reload my page, oh, you'll see it, it's already here. Website is hacked. So this is allowing an unauthenticated person to be able to add, delete, post, change, do anything within my website. So that's like a really, really, really critical flaw. So this is the scariest vulnerability that we've discovered. And this is kind of existent in, I'm going to say, a majority of Lovable created applications that have authentication within them. So a lot of you sent through your applications for us to review. We have reviewed a lot of them, not all of them yet, I will send you emails with kind of what we've found, but a lot of you would have gotten emails to say that, hey, we found a row level security issue in here. So how do we solve that? We have to solve that from our Superbase database by adding in these things. So in this case, I need to make sure that I delete all of these policies that allow for the public role. I need to create new policies. So you don't need to become a coding expert to have a secure, lovable site. You are going to have somewhat of an expertise in creating and understanding row level security. The good news is that you can interact with it with the Lovable interface. So you can say to it that it has a row level security issue within it, and you can ask it to fix it, and it should update those policies for you. You then need to be able to verify that. Now, I did something quite cool in my Lovable application where I got Lovable to actually create a security checker for me, a tool that I can use to check to see if my site is secure. And Lovable did a good job at setting that up, and it did a great job, and it did really quite well in understanding that. All right, I'm going to move on from this. I feel like these two, secret detection and row level security, or understanding the authentication flaws, this is something that you really need to understand and get into. And making sure that your application is secured from that. Essentially, how Lovable works is it relies all of its security on that row level security system. So if that's not set up well, then the whole thing kind of falls over. Now, the good news is that if you set it up well, using row level security is actually very secure. So if we set it up well, we can have a very secure site for that aspect. If we don't, the whole ship kind of sinks. So just be really aware of that. Next, I want to talk about DAST scanning. It stands for Dynamic Application Security Testing. So you've done some secret detection and you're all good. You've established row level security and you've set up your areas. What else can you do? Well, what we need to do is we need to scan our site with something called DAST. Now, what is DAST scanning? DAST scanning is essentially, like, think of it as a hacker inside a box. It looks at your website and it tries to attack it at various different ways. And it does this by trying to understand if it has injection vulnerabilities, making sure that it has the correct security headers. It's going to look at trying to find things like tokens in your site. So it's kind of, think of it just as an out-of-the-box hacker. You feed it your URL and it will do a scan for you. Again, there's a bunch of DAST tools that we can use. Aikido is the one that I'm obviously going to demo. There are some free tools available. Zap is one of them. Nuclei is another. So you can use these tools, plug in your domain, and actually run a scan. Of course, I have a scan already done on Aikido here. And if I go back to our feed, here I'm monitoring. What I'm going to do is I'm going to just limit to my DAST surface monitoring. And you'll see that it's found 3 issues within here. One of them is critical, one of them is high, and one of them is medium. So how I did this is I added in my domain. This is the domain of my Lovable account here. And then I also added in authentication. So I gave it the role of a user, and it essentially authenticated itself into my site. You can kind of see it doing that now. And then it ran a whole bunch of additional checks. Those checks are things like, if I log in as a user, can I become an admin? Those types of areas. So that's what's really cool about DAST. So if I go back to my feed and monitor by DAST scanning, you can see here the content, the content security header. It's found this. This is a really, really important thing. So the content security header, or CSP, is really your first line of defense for a huge amount of security issues, namely things like cross-site scripting. So what does this do? This is a security header that sits inside your application, and it determines how it communicates with external endpoints or external sites. So that's like really important of how it does. So if you have someone that tries to put a malicious script and embed it onto your site, this is something we call cross-site scripting. A content security header will limit how that script actually interacts with that third party, essentially stopping it. Not having one of these is a huge risk. So how do you actually solve that? Well, there's a few things that we can do to solve it. We need to add in a content security policy header. Now, if you don't know how to code and you're kind of going on this, how do I add in a content security policy header? Well, this is something that is really cool about Lovable and Aikido, is that right down here, I have this this how to fix it area. I can really just like copy this how to fix it and then give that to Lovable. So if I go back to Lovable, for whatever reason, I'm having some issues with Lovable. I think Lovable just updated the UI right now. I'll see how this works. But basically, I can say that I don't have a CSP set. And then I'm just going to paste this like fix here and paste this in. And what Lovable should do is then go through and create that header for me. So here it's saying that it's going to add a content security policy in my tags, everything like that. So it's going to do a lot of areas in that for me. Now, what I've found with Lovable is it does this and it adds in the header, but it kind of doesn't configure it always perfectly. So what you need to do is you need to kind of go back to your scanning tool, in this case, Aikido, and once it's fixed it, check to see how it does. In my case, what it did is it fixed this kind of critical issue, but it introduced a different kind of issue that was high. So it is getting better. And then you just need to keep doing that with all the issues. The same for this HSTS header. Again, just going to copy the how to fix it, paste that into Lovable, and then go ahead and move forward on that as well. Now, I'm running out of time. I've got 10 more minutes left, and I kind of want to get to questions and interact with you. So I'm going to kind of rush through a couple of other things at the moment, but it's going to be really important for you to understand these. But I will say is that you're going to get an email after this with what we call the vibe coding security checklist. And it's going to cover a lot of these things. So you're going to have more information from it. But the other area that is going to be really important for you in security is something called software composition analysis, or SCA. I know there's a lot of acronyms. I know there's a lot to uncover, but hopefully we'll be able to kind of sort of get there. Now, what I need to say about SCA is around about 85% of the code in your application doesn't come from Lovable and it doesn't come from Supabase. Where does it come from? It comes from open source components. Now, you think about it like this. If you have to do something simple in your website, let's say that you want to discover the IP address of who's visiting your user, and someone else has that exact same problem, and they've created a tool to do that. And what they do is they make that tool freely available. And then I go, that's fantastic. I'm going to take that tool. I'm going to use it myself. Now, extrapolate that to almost everything. The reason why websites look so much better now than they did in 1999 is because we have all of these open source tools doing all these great things that enable us to just focus on areas. Now, Lovable actually introduces a huge amount of dependencies in our project. And you can think about it like this. So we have our application, and then we have our first row of open source dependencies. This is what Lovable has introduced to make our application run. I will show you where you can see what these are in a minute. The problem where this gets a little bit more confusing is that they also have dependencies and they also have dependencies. So while Lovable may introduce, let's say, 10 dependencies, the actual amount of dependencies that your application is reliant on is probably 100, 1,000, maybe more. To make matters worse is that all the third-party services that you may be using, so if you're using Stripe, if you're using Algolia, if you're using Okta, all of these also have open source components that they rely on. So that makes it like really confusing to understand how your application is interacting with all these things and what it's dependent on. Why is this important? Well, what happens is that these open source dependencies often have vulnerabilities within them, and they can be really significant. If one of these kind of gets turned malicious, so you see this here, this little red dot, it can have an upstream effect and kind of turn your application malicious. So there's a couple of examples that I kind of want to quickly go through before this. But first, let's have a look at how this works in Lovable. So if we go to Lovable and we click on dev mode here, let's see if it works. Yes, it does. This gives us the code. What I'm looking for is something called a package.json file, which is this right here. And you'll see this, all these dependencies. These are the dependencies, the open source tools that Lovable has introduced. You can see that there's a huge amount. There's about 60 of them that it's introduced, that it's now relying on. It also has something called dev dependencies. These are a little bit differently. These are what it uses to create your site, but they're not really exposed at your site. Now, the reality is that I actually am reliant on a whole bunch more than just these 60 tools. And I'm going to show you that right now. If I go back into Aikido security, I'm going to generate a report of something called licenses and SBOMs. And this here is giving me all the components that my application is vulnerable for. There's 10 per page, and I have 63 pages. That means that I have exposure to 630 dependencies within my application. If any of one of those has a big vulnerability within it, then my application can have that same vulnerability. And this is how a lot of attackers work, because it becomes public knowledge that this dependency has this vulnerability. You can find out what sites are using that dependency, and as an attacker, I can target your site like that. So I'm going to skip over this a little bit, but there's a few different attack paths that attackers can go down before we move this. And it kind of, this meme here really illustrates it, is you have all this modern infrastructure. So you can say that your site is sitting up here, your Lovable site is sitting up here, and there's some open source project that someone's been maintaining since 2003 that the whole internet is vulnerable to or exposed to. And if that falls over, if that becomes vulnerable, then the whole internet collapses. And that's actually happened more than once. Believe me, you may not be aware of it, but believe me, it's happened more than once. I want to give you a couple of examples. There's a tool called UA Parser. It does something very specific. It lets users know what the users of your website are viewing it on. So, for example, if you want to know if people are viewing your site on a mobile application or a desktop application, this is a little tool that will do that. It's very reasonable that Lovable will introduce your application to this. It has a huge amount of weekly downloads, 10 million weekly downloads. It has lots of versions and lots of dependents. All of this means is that this is a very reputable project. But here's what actually happened. On a Russian dark web forum, someone posted that they were selling an account. They were selling an NPM account that they had kind of gained access to. This account was for this project. Essentially, what it meant is that someone had taken over this project maliciously and that they were going to sell access to it. Why would you do that? Because then a threat actor can inject malware into that site. And that's exactly what happened. Malware was included into this user. In this case, it was a crypto miner and a credential stealer. So what does that mean? It means that if your Lovable site is using this component and this component gets turned malicious, your application is now a vehicle for attackers to steal credentials and mine crypto. That's going to give you a gigantic bill because your application is going to be using huge amounts of resources, and your users may get attacked or their credentials stolen. Now, in this case, Lovable did nothing wrong. You did nothing wrong. It's just an attacker that targeted what we call the supply chain. This happens a lot. It even happened this week. For Aikido, we actually discovered this ourselves. The SDK for Ripple, which is a cryptocurrency, the official SDK for Ripple by the Ripple Foundation, was turned malicious. Here again, a malware was inserted to connect to and a backdoor was added. If you were using this package in your site, you would now have a backdoor into your site, and people would be able to try and steal your users' information. Now, I know this is all scary, but there is a way that we can deal with that, and that's something called software composition analysis. So I'm going to go back into Aikido. I'm going to go into my feed, and I'm just going to look here at open source dependencies. And what this is showing me is all the dependencies that I'm using that have vulnerabilities. So for example, this roll-up dependency that I'm using is vulnerable to a cross-site scripting attack. Now, how do I solve this? I need to upgrade my package. So this is the vulnerable version. This is the non-vulnerable version. Basically, you don't need to worry about that. If you have this vulnerability in your Lovable website, you need to go back to Lovable and you need to tell it that I have a vulnerable version and I need you to upgrade it for me. Lovable will then upgrade that. It will check that it's all working and you can move on with your life. And you can check back in something like Aikido that that's then been resolved. So that means that you can make sure that none of these vulnerable components or components that have malware in them will actually affect you. So this is going to be a very important part. Now, unlike a lot of the other vulnerabilities, this is not something that you need to worry about once. You need to say, oh, I do this once, I have no issues with my vulnerabilities, now I can move on with my life. These vulnerabilities become vulnerable or they become malicious. So you need to consciously monitor this. I know that sounds scary, but that's just the reality of where we are. You need to consciously monitor your open source dependencies from this. There are a few tools to do this. Obviously, Aikido is the one that I just showed, but we also have things like Dependency Check, Dependency Track, and Trivy. So you can use those open source tools. Obviously, I'd recommend Aikido for a number of reasons, but we can go ahead on all that as well. Now, I'm running out of time, so I'm going to kind of race through the last couple. The next one that you need to worry about or do is something called Static Application Security Testing, SAST. Now, this is a tool that looks at your source code in and of itself. It scans your source code or the source code that Lovable creates, and it tries to identify any vulnerabilities. This one is slightly less relevant for you as a Lovable user because the code that Lovable creates is really only front-end code. So there's not a whole lot that can go wrong. But it's looking for things like insecure functions, input validation, access control flaws, or sensitive data exposure. Now, in my case, for my Lovable site, I didn't find any issues in how Lovable created my code or any vulnerable code. Again, this is because it's mostly front-end code, but it is really important to also have this in your project as well. And there are some tools that you can use for that. The final thing is that I'm conscious that I'm running out of time now is firewalls that we need to add. There's a couple of different types. The main ones is a WAF, stands for Web Application Firewall, and there's other ones called a RASP, Runtime Application Security Protection is what that stands for. But essentially, firewalls kind of work, well, there's a big logo in there. I think that was, that was a mistake. But anyway, firewalls basically work that if an attacker is trying to attack your site, then it's going to block any malicious traffic or any malicious attempts. A web application firewall sits outside of your application and just kind of looks at the traffic coming in and blocks it. A RASP or an in-app firewall will sit inside your application and you can do more things with it. So there's areas like you can use Aikido Zen for an in-app firewall. There are some issues in getting this to work with Lovable at the moment, but we're working on that. And there's also external WAFs, something like Cloudflare. It's really important that you introduce these as well. And essentially, this is kind of your last line of your defense of what you want. So, all right, we've made it. We've made it to the end on time. I hope that's been interesting at the moment. I haven't been able to look too much at the chats going on, but I see that it's been happening a lot. But like, what do you need for it to be secure? Well, there's a couple of things. Critically, you need secret detection, and you need to look at your authentication and design flaws. What's critical to this is understanding row-level security. This is absolutely central to your site, and I can tell you from when you've added your sites that there's a lot of you that are hopefully watching this today that are very vulnerable to row-level security in your sites. You need to check your policies around that and understand that. Next, we can scan our site with our various different tools like DAST, SCA, Static Application Security Testing, and firewalls. Once you've done that, you can start looking at things like license protection, end-of-life, malware detection. We'll worry about that at a different webinar. Right now, what you need to worry about is secrets detection and authentication and design flaws. And what can really help you is using a tool like Aikido. But as I said, I've given you other options if you don't want to use Aikido to be able to go through and sit in there as well. All right. Now, there is a Q&A open on our site. You can see there you can ask me any questions. So if you do have any questions about your site or about information about what we just said, then I'm happy to take those now. And I think see there we have there that my authentication is done on Supabase. Like is that going to be secure? Supabase can be secure, and what I really want to stress is that Lovable and Supabase is quite a good connection that they've made. It's restrictive in what Lovable can create because of this. However, I think that's the correct approach because it means that they can focus on making that secure. However, what I have noticed is that the Supabase really needs to be set up correctly. And you're going to need to understand this level for that to work. So it is secure, but you need to kind of set that up correctly for that. I'm just going to go look through some of the chat right now to see if there's any questions. Oh, we have some new messages. Yeah, any questions, drop them in the chat. I'm happy to kind of answer them now whilst we're going. But hopefully that will give you kind of an understanding of what you need to do immediately to secure your Lovable applications. What are Superbase edge functions? Okay, let's have a look here. So Superbase edge functions here, you see this, you'll see this here saying edge functions. This is essentially the back end of your application. What Superbase does is it creates a mini, let's call it a mini application within it that deals with a certain component. We would probably call these microservices. And this is, yeah, this is all part of an umbrella called serverless architecture. What's really important here is that you have, so I have all these functions. So subscribe to my newsletter is a function. If I look in that, there's a whole bunch of code that makes that possible. This is like a little function inside Superbase for it. What's really important is this secrets tab here for functions. Here you'll see a whole bunch of secrets. Now this is the SHA of the secret, so it's not the actual secret, it's a hash, but just know that that's secure. This is where it's storing all of my secrets in for my edge functions, for my back end of my application. This is correct. This is secure. So when you were looking at your edge functions, this is what it's doing. It's creating a mini service in there, and then it's putting its secrets that it needs for that in that edge function. So really, really important things to kind of know about that. But basically, what you need to know is when you're adding new functionality to your Lovable site, it's going to create an edge function in Superbase. This is kind of the backend functionality. If it needs secrets to deal with that, it should put them securely in here. This will load them as environment variables, and all of this is safe. Should we create the app roles in a table, or does Superbase provide some additional functionality to manage these? I would make sure. I would. Superbase should be kind of managing this in a database. So authentication it does do in a database, in a table in and of itself. I would make sure that you go through the Lovable process of creating authentication. This is quite complicated. Superbase does a great job. Now, I have to kind of be careful what I'm saying here is because there's huge risks in creating this, and from my experience, Lovable can get this quite wrong. But once it's set up correctly, the Superbase authentication is really cool. And what I kind of really want to stress, as I said, that this is a bash-free zone of Lovable. What Lovable does really well is super impressive, and it creates amazing sites. But we have to think of it as a tool and not like just the absolute solution. We need to go in there and take a bit of responsibility for security ourselves and understand this. So go through Lovable, and then you want to make sure and you want to look at your table flows. So this element here, especially as it gets more complicated, to see how, for example, your admin users are connected to your articles table, areas like that, and go through it. And then you want to make sure that you have your policies set up correctly. Okay, so there's a few more questions about setting up Superbase securely. Yeah, I'll create some content around that. Do you guys want me to create any other content? I'm happy to. Here's your chance. I'm happy to to create content for you if you want it to be secure. But yeah, that brings us to the end. We're kind of at the top of the hour for you. Now you can follow us at Aikido Security on any of social media. You can follow me at the handle @AdvocateMac. You can connect with me on LinkedIn if you want. Happy to chat. Happy to answer any further questions for you. As I said, we've actually created a bunch of content that's going to follow up from this. That includes a video from me going through this at a different level. So you'll be able to rewatch that. You'll be able to rewatch this webinar as well eventually. And we're also going to send you some content called the vibe coding security checklist. This is going to go through a little bit of what we said. So you're going to get some more supplementary content with you as well. So make sure you subscribe and stay tuned. We'll follow up with you to make sure you have that. And if you provided us with your link, lots of them, we got hundreds of them. So we're slowly kind of trying to get through them. I'm probably not going to be able to get through all of them. I'm just going to do who gave us them there first, but we'll try and get back to you with some of the security issues that you have in your site too. I think a few more questions about securing apps built on Lovable but connected to Superbase instead of MySQL. Well, basically everything I've talked about is about how it's connected to Superbase. What I would really recommend is that you stick to that Superbase that Superbase flow. I think like what Lovable is really good for is creating these MVP type products or like home pages or simple things to kind of get you started. And I would like absolutely religiously stick to the flow that they have, because once you get outside of that, it's going to get more and more complicated for you there. The checklist will go out hopefully tomorrow. So I will be sending out that checklist tomorrow for you, for everyone. So it's the person that just, so yeah, Madeline just replied tomorrow. All right, well, we've made it to the end of the hour. I'll have a look. Again, if you have any more questions, follow up with me on social media. Send me a tweet or whatever they're calling it now on X, or send me a message on LinkedIn, and I'll be happy to follow up with you and have a look for it. So I hope you found the webinar useful, and I look forward to seeing you all on the next one. So make sure you stay tuned. All right, thanks everyone for staying true, and I'm going to end the webinar now. Or Madeline will end the webinar and I'll leave, whatever.